Good evening to everyone who are watching this video. Myself, VENKATA TEJA from Puducherry Technological University. I'm currently in my final year of BTech. I took this internship from Emertxe on IoT. I really learned something from this internship, and I'm going to share everything which I learned and what I implemented during this internship in the following slides. At first, we'll see what is the present agenda of this presentation. Now, I'm going to discuss what I learned in this internship, and then what is nothing but IoT, and what I implemented using that IoT, and the projects which I implemented, and finally, at the end, I will show the demo of the project. Now, coming to what I learned. So, if you take an IoT is a combination of both software and hardware. So, if you go for software, its main is nothing but the programming, which currently in this internship I used Arduino IUD, so which basically code in a C language. So skills on C language, C programming is very essential in doing IoT projects. So what I learned is the how the software development will be done, how the embedded system software development will be done, and how the firmware and middleware and the driver development will be done. In the first week, everything we covered was the deep concept of the C, which we covered in the first week of this internship, which I took. And I'm going to show the topics which I learned from the C programming. Uh, as I'm from EC, I have a little bit knowledge on the C programming skills, so which I found very easy to learn or which very easy to recall again. So the concepts are the keywords. What keywords is nothing but a special words which are dedicated for a special purpose, which cannot be used as a normal variables, such as if else, while, for, etc., which has some purpose in the programming, which can't be used as a normal variable, and data types, which is nothing but int, float, char, double, short, etc., unsigned int, which generally shows the type of data which you are dealing with. If nothing but integer is just now 1, 2, 3 numbers. If it is a float, nothing but decimals. If it is a double, nothing but a greater numbers than int, like that. And then the conditional operators, which is nothing but the else if conditions, for, while, do while, etc., which will very essential in doing a programming like a loop functions. And if you go for operators and modifiers, operators is nothing but the bitwise operators, which I learned in this internship, like a left shift, right shift, etc. And the modifiers are also used for that purpose. And if you go for array concepts, an array is nothing but a data structure which holds a data in a sequential manner, like in sequential memory locations. And it will show, and remember, it will show the same data type, not a different. If it's going to store 10 values, it will be all of same data type, like all int or all float, like that. And if you go for pointers, so pointers is nothing but it actually have the address of the variable. Like if you have a value 10 stored in a memory, a pointer to that variable will say at which address that value is stored. Similarly, the functions, which is very important in a program. So if without functions, a code will become a very large code. So if you want to use a particular operation continuously, or particular step of procedures continuously, you should make use of the functions. And strings is nothing but an array of characters. So a character is nothing but a normal letter. If my name is Teja, a T is a character, but Teja is a string, kind of that. And memory and storage classes. So memory is nothing but you will be having, how the memory allocation will be done, a malloc, cloc, and how the storage classes will be there. And if you go for concepts and header files is nothing but the files which include a predefined functions. Like if you go for um, in C program, if you go into print, You don't need to give a set of code just for just print. You can use a simple function print which will be defined in the header files, which is nothing but the preprocessed directives, etc. And macros is kind of functions, but it's not function. Like macro will be defined by a name, and that name will simply paste the code which we defined in the beginning of the entire code. So it will get compiled again and again. And now we move after the C um, concepts which I learned in my internship. I learned C++ concepts also after the C concepts, such as first they told me the main difference between the C and C++, which is nothing but C is a procedural language, where C++ is also procedural language, but along with it supports object-oriented programming, which is nothing but polymorphism, inheritance, data encapsulation, etc. So what is a structured concepts? So structures are mainly used in C. So you'll be having two types: the structures, which is used in C, and classes and objects, which are used in C++. So structures can hold a different types of variables of different data types into one, whereas a class can store different members and also member functions, where the structures cannot store the member functions. And access modifiers are mainly used in C++ object-oriented programming, such as private, public, and protected mode. Like public means can be accessed anywhere. Protected means can be accessed only within the functions. I mean within the functions or subclass of that function. But private can be accessed only inside the class, nothing else. And constructions or destructors are mainly used in creation and destruction of the objects. When an object is created, a constructor is immediately called. When an object is gone out of the scope, then it calls a destruction. These are the few C++ concepts that I have learned during my internship. And coming to what is IoT, our second agenda, the main concept of this whole internship. What is IoT? So I'm going to give a brief introduction to the Internet of Things. So what is the reason for IoT getting like so much value nowadays? Like it's going rapidly today. It's because the hardware is getting cheap and the M2M solutions are the mainstreams. So the connectivity is the main thing. Like if you want to control anything inside your home, it need not be you should present inside your home. It can be outside your home, or if you want to control any device in your home, you can be in any surroundings of that, no need to present at the position. So it's giving a connectivity, and software is getting more and more advanced with cloud technology and etc. So which gave rise to IoT. So generally, what are the requirements will be like, you will be having many devices, like you can say TV, fan, fridge, etc., etc. And you should have a volume of data for storing all the things and end-to-end integration between them. And you should have an application which controls both them with a security. So what are the challenges is the addressing the data volume. If you have many devices, the data volume will be increase exponentially, and the connectivity will also become a real challenge in this environment. So what is the principle? So we will be using for addressing like a sub system, a pub. It's nothing but a hop which gives connecting to everything. And for data volume, large data volume, we'll be using cloud storage, which is very much used nowadays. And for connectivity, we'll be using queues. Like if both are two devices accessing the same function, then it will be stored in a queue. After the one perform their function, and another will perform next. Now move on to the a simple architecture. I have took a picture from the internet. It just shows how the architecture of the IoT will look like. So you'll be having a device connectivity module, and you will be having a data processing and analytics module, and you'll be having a presentation module. So device connectivity can be done in two ways. If it is of a IP capable device, you can directly connect to the cloud gateway. If it is a low power device or a old IoT devices, then you should be using IoT client gateway to connect to the cloud gateway, and that will be connected to the IoT backend and at the end presentation. Now moving on to IoT, from IoT to embedded system. Embedded system is also a subtopic of an IoT, because embedded system is nothing but combining the software and the hardware integrated together. So any combination of hardware and software which are intended to do a specific task can be referred as an embedded system. So if you are going to control a robot by using a keypad, then that system is nothing but a embedded system. So you'll have both the hardware, that is nothing but the robot, and you'll be having software which is connected from the robot to the keypad. So what are the components? So you will be having the microcontrollers and microprocessors, which are the main heart of the whole system, and you will be having some chips which are intended for specific purposes, and you will be having memory, which can be RAM, ROM, EEPROM, flash, etc. And the main thing is sensors, which you will be utilized for a different purpose. And actuators. So what is difference between sensors and actuators is nothing but a sensor will sense the value, and it will give the value to the microprocessor, microcontroller to do operations. And the output, if you want to show any output like movement or vibrations, anything, that will be done by the actuators. So human interface, of course, you will be having LCD, LED displays, which you should present the output or input to the humans. And you'll be having ASC, used for application-specific integrated circuits, ICs, and auxiliary systems, which includes power and cooling systems. Now, these are the main core topics which I learned. From now, I'm going to explain what I implemented by gaining these knowledge. So in this internship, I have done a project which includes three peripherals. So three sub projects combined as in one project, which is nothing but home automation solution. So it will consist of the first one will be of controlling the garden lights during day and night time. So it's very useful in daily use, because if the daytime the sun will be there, so there is no need of lights. So when the sun brightness increases, the light will automatically off. And at the night time when the sun sets, the light will automatically glow slowly and it will become bright. So it is used mainly to save the energy. And the second is controlling the cooler and heater systems, nothing but the temperature systems. If the temperature we design such that if a temperature reaches a point, then the heater will stop, and if it goes below some point, then the heater will on, like that. So controlling water tank inlet and outlet pipes. So generally you'll be having a water tanks. So it will control the inflow and outflow of the water. If the water is getting too low, then the inflow will be on. If water is full, then the outflow will be on, like that. And now we are going to see the first one. And what are the project requirements in the whole this? So main microcontroller or main heart which we are using here is nothing but the Arduino Uno. So Arduino Uno is a microcontroller board based on the Atmega 328. It will be having 14 data input and output pins, and which 6 are used as a PW outputs, 6 analog inputs, a 16 megahertz ceramic resonator, and you'll be having a USB connection which to load the code, etc., and a power jack, DC power jack, and an IC SP header, and a reset button will be present in the Arduino board. It contains everything needed to support the microcontroller. It is the latest microcontroller which is widely used in many applications nowadays. Simply, it can be connected to a computer with a USB, or it can even power it with a AC to DC adapter. A battery can get started. So operating voltage will be of 5 volts. So total 14 pins will be there, of which 6 provide PWM outputs, and analog input pins will be of 6, and clock speed is of 16 megahertz. So this is the and here is the I will take the pointer. Here is the simple pin diagram of the Arduino Uno board. Now if you go for output components, so main components which we will be using are LED and CLCD boards. So LED, it is the simplest device used in the embedded applications, as feedback works just like diodes. It's nothing but a diode, light emitting diode. It can be used for home lighting, remote controls, surveillance, and many more. And it has two types of thing: sourcing and syncing, and a CLCD, character liquid crystal display, which is nothing but an LCD display, which will be basically a 16x2 LCD, and it has two types of mode: 8-bit mode and 4-bit mode. So these are the some of the functions which are used for LED and CLCD. Like if you just need to on an LED, you can't simply press a button. I mean, you will press a button, but at the back end the main thing will be done by these commands. So pin mode, first you have to select that the particular pin is output or input. So pin refers the pin number, mode refers the output or input. So configures specified pin to behave either as input or output. Digital write, whether you want to write whether you want to active the pin, or you have to low the pin, like high or low. And digital read, and you can just get the data whether it is high or low. A delay ms is basically used to pause the program for amount of time, which is very useful to show the output for a human naked eye. For the use of LCD function, you have to include a liquid crystal I2C. This is the function first you have to include to use the LCD, and then you will be initializing the LCD by LCD init, and then you have to turn on the backlight, and then you will be which is LCD dot backlight, and LCD dot clear use it to clear the screen, and LCD dot home will set the cursor to first point. It's like resetting everything. And you will be using set cursor column comma rows. In column you will be having like 16 columns, but you will be having 2 rows to set cursor at particular position. And print string, like print LCD dot print, will just transfer the data to the LCD, and it will be get printed there. And now if you go for blink IoT, so okay, LCD will be shown, but LCD is of an old technology. Now the IoT is nothing but connecting it with your smartphone, connecting it with your laptop, everything. So it will be completely wireless. LCD you can't connect wirelessly. You have to connect it with wire. But Blink IoT app gives facility which will be connected over Ethernet. So Blink is a full suite of software required to prototype, deploy, and remotely manage connected electronic devices at a scale, from personal IoT projects to million of commercial connected projects. So Blink IoT is widely used throughout the world. So with Blink, one can connect their hardware to cloud and build no code iOS Android web application. So to build a web application, you need no coding. Just by using make use of winglets, you can just add the buttons, you can add just a gauge to see the volume up and down, etc. And we'll be using serial tank to control a real life tank. So you'll be having a inlet and outlet walls. This is outlet, which is the inlet, and we'll be setting this volume to 3000, and we'll be showing in further and demo. And what are the functions that are used for blink app and serial tank? So blink underscore write is a function called every time a device gets an update of virtual pin, and param as int, these are used to get the data. And virtual write sends data in various formats to virtual pins. Set interval, just it delays a period of time. Serial dot begin sets the data rate in bits per second, and serial dot write, so it writes the binary data to the particular serial port. And serial dot read, it reads the incoming data at that particular thing. For analog input and analog output, so analog write will be read to write, and analog read is used to read. Now going to the project individual peripherals. So first peripheral is controlling garden light. So problem statement. So this project is about to controlling the garden light using the peripherals. So the outcome will be the light glows when the surrounding becomes dark, and light stops glows when the surrounding becomes bright. So there is a variation of brightness of the LED with respect to the surrounding. So for this we will be using LDR sensor, light dependent resistor, for controlling the brightness of the LED according to the surroundings. So LDR sensor value becomes high when the surroundings become dark, and LDR sensor value become low when the surroundings is bright. So read the LDR sensor value based on the reading, vary the brightness. It's just simple peripheral. So we'll be having Arduino Uno board, and you'll be having a LDR sensor and the lights. So LDR sensor will be connected to the Arduino Uno board by means of A1 pin, and lights will be connected to Arduino board by means of GPIO 3 pin. So now I'm going to show a screenshot of my project which I took. So here you can see the LDR value is low, which means it is of daytime. So sun brightness is very high, so there is no glow in the LED. So we can see that there is high brightness and the LED doesn't glow. So this is the LDR module, and this is the lights, LED lights, and I'm going to like we'll see that. And this is the output. Like if the LDR values become high, which means the outside become dark, so the garden light should turn on. So see, the light will be turned on. Here we can see that when there is a low brightness, the LED grows bright. This is the first peripheral. Moving on to the second project. So temperature control systems. So the temperature control system consists of a heating resistor, an LM35 temperature sensor, and a cooler, which resembles the temperature control system at home. So it reads the temperature from the temperature sensor and it displays on the CLCD. And not only display, it will control the temperature. You can turn on or turn off the heater and cooler through the Blink IoT mobile app. So what are the requirements? So you'll be requiring a temperature sensor for this, a cooling, heating, and temperature sensor module, which will be included in the temperature system, which can be readily available in the Pixim Lab simulation. And we'll be needing of Ethernet shield, which is which establishes connection between the Pixim Lab and the Blink application, and you'll be having a Blink application in your mobile to control the system. So threshold temperature control. So you'll be having what is the process? Read and compare the temperature with 35 degrees. So we are keeping a threshold 35 degrees. If the temperature is more than 35 degrees, it will turn off the heater and send notification that heater is turned on. If it is below the 35, then the heater will be turned on. So outcomes. So temperature control. The outcome will be display temperature on gauge get and display temperature on LCD. So in hardware, it will be displayed on the LCD, and in mobile app, it will be displayed as a temperature gauge, like this. It will be displayed as a temperature gauge. And what is a cooler control system? So it detects the change in logical level. If the button winget is at a logic high, turn on the cooler. If the winget is at low, turn off the cooler. Similarly applicable for the heating system. So this is the architecture for the connections. So you will be having Arduino Uno as same, and CLCD will be having. Apart from that, you will be having temperature system and a Blink IoT. So Blink IoT will be connected to Arduino, and temperature system will be connected to Arduino. So Arduino is the main microcontroller that connects everything and operates in between. So the temperature will be connected through means of A0 pin, and heater control will be connected to means of pin 5, and cooler by means of pin 4. And in Blink, the temperature will be connected to V1 pin, and heater to V2, cooler to V0, and notifications to send to the Blink app will be using V6. And in LCD, you will just send the notification on the what is the value of the temperature exists. So you can see here the heater is connected to the pin 5, and the cooler is connected to a pin 4, and the temperature is connected to A0. Similarly, in I2C module, so we will be using I2C module to connect to the LCD, where we will be connecting the SDL to A5 and SDA to A4. Similarly, the Ethernet shield will be having properties like P3 will be connected to the 12th pin, P5 to 11th pin, P6 to reset, P7 to 10th pin, and P9 the clock to the 13th pin of the Arduino Uno. And similarly, these are for LEDs and these are for the temperature systems. And for serial tank also we'll be using the same LCD display, serial uh, apart from the serial remote tank, which we can get from here, which will be connected to the COM. At the end I will be showing the demo of this. Now this is the connections, and yeah, you can see here this is the screenshot I took from my simulation. So here you can see the temperature is 27.37, which will be displayed in the LCD. And similarly we will be seeing the heater off because the temperature is below 35, the heater is become off. Similarly, so I mean if it is below 27, so the heater will be on. Now here you can see the temperature is 34.21, which will be displayed, and heater is off. Now project 3, water tank inlet and outlet valve control. Nothing but you can just assume it as a simple tank which you will be using in your home. So project statement: read the volume of the water in the tank through serial communication, and it will be displayed on the CLCD, and it will also show in the mobile app, Blink IoT app, and you can control it by using Blink IoT app. So what are the requirements? You will be requiring a remote serial tank which can be easily available in the PIXIM simulator, and null emulator for COM connection. So connection between the PIXIM and the serial tank, you will be using null emulator, and Ethernet shield to connect to the Blink IoT, and Blink app for controlling the inlet and outlet valve using the mobile phone. So what it will display? So read the volume of the water by sending commands to serial communication. Display the volume of water and gauge winglet, and display on the volume of the water on CLCD. So inlet valve control. So it detects the change in. If the button is logic high, then turn on the inlet. If it is low, turn off the inlet. Similarly for the outlet. And control the volume. How you will be controlling? If the volume of the water in the tank is less than 2000 liters, then turn on the inlet. So it becoming low. So you'll just giving water to the tank. And send the notification same to the LCD and the winget, mobile app. If the volume water reaches 3000, then turn off the inlet and turn on the outlet. It's not necessarily you should turn on the outlet. So if you want to reduce the volume, if you want to see whether it is working, you will just turn on the outlet. If it becomes below 2000, if the inlet on, then it's working perfectly. So these are the connections similar to the Arduino, like previous experiment. You'll be having CLCD, Blink app, but the volume of the water will be connected to V3, inlet valve will connected to V4, outlet valve will be connected to V5, and notifications to V6. It is common. So these are the data streams which will be created in the um, Blink IoT app. And water tank, we will be using COM6 for, common COMs for Arduino. You'll be using COM6, and water tank you will be using COM7. And by using null emulator, you will be connecting both these COMs. And here is the screenshot of the thing which I took. So here you can see the serial tank is connected to COM7, and of course the Arduino will be connected to COM6. Here you can see the volume is 2120, so which will be shown here. So the inflow is off because the volume is above 2000 liters, so inlet should be switched off. So which we can see here. the volume becomes 3000. I mean, uh, if it becomes 3000, sorry. Here, once you see, when the water level is full, the water inflow is disabled, and the water level I made it become below 2000. Water level will is enabled. So it will be when it will be enabled until it reaches 3000, it will be enabled. So once it reaches 3000, so water level is full, so water inflow will be disabled. So once it full, water inflow will be disabled 3000. Here you may think why it is showing temperature also. So I included all the experiments in one file, like all the code into one file, as I was taught in the internship project. I mean internship video lectures. Both the LDR temperature system and the serial tank control is included in one. Here I will be using tab 1 and tab 2. So tab 1 is used for temperature system, tab 2 is used for the water level control in serial tank. So these are the presentation slides, and at the end I will be showing the I will now after this I will be showing the project demonstration, and at the end I will be giving my thank note on my experience in my internship. So now I'm going to show the project uh, demonstration.
Now we will see the LDR sensor. If it is a night time, darkness will be more, so LED will be glowing on. If it is a morning time, the brightness will be low. I mean brightness will be high. LEDs will be switched off. You can see now LED is switched off. This is how the LDR sensor is going to work. Here for temperature experiment, we'll be opening Blink app, and now we can see the temperature. And if I switch on the cooler, like the cooler will be switched on as you can see, and now the temperature is 27 when cooler is on. Now if I switch on the heater, the temperature will be increasing, but it will increase up to 35 degrees centigrade, and then the heater will be switched on as we can see now. See here the temperature is about 35 degrees Celsius, and the turning of the heater, this is the thing, and now has decreased by 35. Now if we again switch on the heater, the temperature will be increased up above 35, and after it will be switched off. Now we'll be seeing the cereal tank. Uh, See, you can see the cereal tank here from fixing, and cereal tank is connected to the COM7, and we'll open Blink app, tab 2. Yeah, now we can see the inflow is off. So the serial tank and Pixel is connected to the COM6, whereas serial tank is connected to the COM7. Now you can see in the Blink app, if we on the outlet, see the volume will be decreasing. Once it decreases the 2000 volume, automatically the inlet will be switched on. Since both are switched on, see water inflow is enabled. So both are switched on, it will be constant volume. So 9550 inflow is on. Now if I let us make the switch off. So now outplay is switched off. So the volume will be increasing, and up to when it will increase? Up to 3000 liters, which is maximum, it will increase, and then it will switch off the inlet. You can see here. Yeah, water is full and water inflow is disabled. Now if I again switch on the outlet, the volume will be decreasing. When it reaches 2000 below, it will automatically on the see inlet, it will automatically on. So water is less than 2000, water inflow is enabled. So this is the serial time. This is the code which I have used for this project. So these are the Blink authentication token template ID, the device name which I gave in the Blink app, and these are the header files which I have included. And these individual header files are declared separately here. And main important thing is these all files should be included in a single folder to work. And this is a blink right and blink right cooler VPN, heater VPN are used for the temperature systems, and the inlet and outlet are used for the serial tank. And handle temperature and handle tank is used to handle the volume, like 35 degrees. If it reaches, then heater should be off. If it reaches 200 2000 liters, then the inlet should be switched on. So these are handled by these functions, and these are the insulation functions, L for LCD, and for all the peripherals, temperature system, LDR, temperature system, LDR, and the serial tank, etc. And these are the normal blinker timer functions which are handled here. And this is the LDR, I mean LDR main functions which we will be doing. So you will be reading LDR sensor value and converting into the high or low value and giving into the LED like that. Similarly for serial time and the temperature system. These are the codes which I have used. And finally, coming to the end of my presentation, uh, in my opinion, this internship really gave me a very thorough idea about the IoT, how we can utilize the IoT for further. So it really ignited my interest towards learning it, and I really found fun making this project, which is like you can even implement in your house for your tank, etc. like that. So I really enjoyed this internship, and I would like to thank all the mentors and organizers who have done these internships for free in these harder times. And finally, thank you.